Generators are great, no doubts about that. But if you have a class and you want to make it behave like a generator, what are our options? Python gives you exactly that. Even though it looks like an overkill, it comes handy to build your custom classes. For example, you have range method in Python which takes two values and loops over them. What if you don't have that? What if you have to build something custom and it should be a class? In that case, Python gives you two methods. These are dunder methods, iter and next. Using these two methods, we can make an iterator which you can loop through. Similar to generators, these are also evaluated during the runtime. Let's see how this happens. First, you have an iterator method. The iterator method should tell which class's next method should I be using. Does that make sense? No, probably not. Let's create another class named range1 and it has the exact constructs. Alright, so this range1 will have a next method which is going to return 0 if self.current equal to 0, okay? And else it's gonna raise a stop iteration. We will come to what stop iteration and all is in a bit, but to give you an understanding of what iterate method is, that is what we are focusing on right now. So let's add this current and make it 0. So the first time it runs, it's gonna return 0, and the second time it runs, it's gonna stop the iteration. So that is what we are planning. To this iterator method, what you can pass is return range1 of, so we have a custom class, range1 of self.start, self.end, and pretty much that's it. Everything else is taken care by this one. So now we have a range class created and we have a list of art. This is very similar to looping over the range. So let's run that. I hope everything stays intact. Right, so it prints 0 and then exits out of this loop. Now let's update this function to do a lot more. Right now we haven't touched the next of it. I will come to that in a little bit. Now this whole loop will run in a continuous loop. Basically, iterators are returned that way, and we will increment the current by 1, and the current will start at start minus 1 because the first loop will be the start. Once the current goes beyond the end, so the current is going to keep on updating. We are still implementing the range class, if you remember. Keep on incrementing, and at the end, it's going to raise a stop iteration. Else, what you have to do is return self.current itself, right? So if you're looping from 1 to 10, what is going to happen is at 1, it's going to return the current value, and at 10, it's going to raise the exception. So let's get rid of this and run the iterators.py. So now you can see it looped from 10 to 20 and then stopped there. It explains us the iterator method. So the iterator method tells you which object's next method that you should be looking for. So it can also refer to itself. What do I mean by that? So let's take this next method and then copy it over here. And instead of doing all this, let's return self, as in it's returning its own object, which is self. It will work the same way. The job of the iterator is to point to a class which contains the next method. This gives you an extra handle that both the iterable and the iterator doesn't have to reside in the same class. Using this construct, we can extrapolate the same idea of file reading to iterators as well. So here I have a class file iterator, and it's going to take a file path, start and end. Doesn't it look like our generators from the previous video? Cool. Now we have set the current line to -1. So what this does is the iterator method is pointing to self, which means the next is present in this iterator itself. In next, what we are going to do is we are going to read from 0th line, which is we get from read line, and then keep iterating it until you are in between the start and end. If you're Anytime you pass beyond the end, you have to close the file and then raise stop iteration. This works exactly like our generators. Let's run iterators.py again. So it's going to loop over. So this is exactly what's happening inside the generators as well, which we saw in the previous video. Pretty cool, right? This is why we love Python. Until the next video, see you soon. Goodbye.